All right, good morning. Advent of Code Day 6. Let's get it done. All right. Your flight approaches regional airport. Have a custom declarations form. Yeah. Formats a series of 26 yes or no questions marked A through Z. All you need to do is identify the questions for which anyone in your group answers yes. Since your group is just you, this doesn't take very long. However, the person sitting next to you seems to be experiencing a language barrier and asks if you can help. For each of the people in their group, you write down the questions for which they answer yes. One per line. For example, ABCX, ABCY, ABCZ. In this group, there are 6 questions to which anyone answers yes. 26 questions, one for each letter of the alphabet. To which anyone answered yes. A, B, C, X, Y, Z. Duplicate answers to the same question and don't count extra. Each question counts at most once. Another group asks for your help with another, and eventually you've collected answers from every group on the plane, which is your puzzle input. Each group's answers are separated by a blank line, and within each group, each person's answers are on a single line, for example. Okay. So if you remember day 3 or something, had trouble with the blank line, but luckily we had an answer to that. Also, shout out to Dave DeLong who called out watching the video. He gave me a tip. It's components separated by an NS string. So I knew something like that existed, but I couldn't remember what it was in the moment. Okay, so the first group contains one person who answered yes to 3 questions, A, B, and C. Okay, got it. The second group contains 3 people. Combined, they answered yes to 3 questions, A, B, and C. The second group contains 3 people. Combined, they answered yes to 3 questions, A, B, and C, blah, blah, blah. The fourth group contains 4 people. Combined, they answered yes to only 1 question, A. The last group contains 1 person who answered yes to only 1 question, which is B in this example. The sum of these counts is 11. For each group, count the number of questions to which anyone answered yes. What is the sum of those counts? Okay, so this is not going to be too bad, I don't think. Cool. So what we're going to do, we're going to take our input here. Okay, so first things first, I'm going to create a struct for a group. We're going to have a struct for a group, and then this group is going to be, let's see, well, the group contains multiple lines, so we're going to have a response also. And then a group is basically going to be a list of responses. I'm changing this to a var. I read a really interesting article about making structs use vars, because if somebody declares a struct as a let, that implicitly turns everything else into a let on it. If you have any opinions on whether your member variables on the struct should be vars or lets, let me know in the comments below. Okay, so let's parse this bad boy out. So equals, let's see, let's start with input strings as I'm pulling this apart. So input as NS string, and then we want components separated by, there it is. That solves the problem that we were trying to solve before. So that gets each individual set. And then, which would then be, this is now an array of strings. And so if we actually want to prove that really quick, so you guys can see last time, this was exactly the problem we ran into. So again, shout out to Dave DeLong for that. Follow him on Twitter, you know the deal. Okay, perfect. See, look, so now it's got, boom, first one is X, new line X. Okay, this is sweet. Okay, second thing is we want to turn each of these input strings, which is this right here, into a group. So what we're going to do is we're going to map this to a group of, which is initialized from a string, which is not an initializer we have yet, but we will in just a second. All right, initialize from a string. And then what we're going to do is we're going to create a bunch of responses. So right now, our response is just going to be it's just going to be some text, but we'll figure out something in a second for that. Okay. So what we're going to do is we're going to take the string. Do I need that? Can I do that? This is like, for anybody that's worked with me, you know that my greatest weakness is initializers. I don't know what it is, but what is and isn't allowed in an initializer driven me crazy. When to use a convenience initializer versus, there's a lot of stuff. Yeah. So that's why basically every time I'm going to write an initializer, I'm like, I don't know if that's allowed. Which is like, this is trivial, right? Putting an underscore as the variable name, but who knows? Initializers have weird rules. Okay, so I think I have, well, let's see if it'll accept $0. I don't know that it will, yeah. See? Again, Lance, if you're watching this, I gotta agree with Dave on this one. I do not enjoy having the substring exposed to me. Okay, so now I've got a response. So the next thing that we need to do is we need to think of, okay, how do we count the unique characters in each one? Now what we can do is we could be really dumb and just say, for A, B, C, D, F, I go through the whole alphabet, and then for the whole alphabet go through each string. Maybe that's the right answer. I'm not, nothing more clever is coming to mind right away, because we have to count them anyway. The problem is, well, and these aren't even sorted, so like, because like, look at this one, Y and Z are at the beginning. So like, I think maybe that is actually the right answer, in which case this response struct is maybe actually useless. So let's change this to be string really quick, since this is gonna do all of that for us. And then we're gonna ditch this, because I think that's what we're gonna do. And then we're gonna say response dot func unique response count is, we're going to count it. Okay, so letters, because we want all the letters of the alphabet: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, S, T, U, V, W, X, Y, Z. I'm just thinking, again, I've been talking about Dave a lot this episode, but I've learned a lot this year so far. I wonder if there's a regex to count unique characters. Yeah. What's this? Count unique characters, replace all. Yeah, okay, well, yeah, I don't know that that's actually going to work for us. Okay, let's just keep going down the path we're going down. For character in letters. Yeah, string.element. Okay. And then we're going to do for string in self.responses. Okay, and then what we're going to do is we're going to say, we're going to have a count. And we're going to return the count at the end. So what we're just going to do is we're going to go through every single letter in A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, got them all there. We're going to go through every single one of them, and we're just going to say, does this string contain that letter, yes or no? And if it does, break out, move on to the next one. Okay, so if string dot contains, yes it is. If string dot contains character, count plus equals 1, and we're going to break. Cool. And then so what we're going to do is then we're going to say dot there's a word for it where you like and I'm not trying to do it here, I'm trying to do it up here because I have the groups right here. Sum, total, oh my gosh, my brain is not working. Swift, collection, reduce, found it. Reduce. Okay. So in this case, our reduce is going to be starts at 0. So what reduce does, reduce basically makes it so that you can take everything and reduce it down to a single value. And in this case, that single value is going to be int. So we're going to take our current value, which is an int. It's going to hand us a group, and then we're going to reduce it. So then we're going to. So what you do is you're going to return current value plus group dot the unique response count. And I think that'll be happy. And then we can just print. So it's no longer groups, it's now just a single integer. All right. Let's take a look at this really quick and make sure this works for a couple of them before we just let it rip. Okay. So first one. Let's do count as 1. They should be in order. Let's pronounce the response real quick. Yeah, excellent. So it's really this first one. There's one unique one. Perfect. 19 unique ones. Oh gosh. Sure. That looks like there's a bunch of uniqueness happening there. Because there's not a ton of overlap between these. Let's go with another one that's easier to read. 9. There's a decent amount of overlap there. Again, I can count all these, but we're on so let's just run it. That looks close. If not, we can go through and debug each of these. Hey, that was it. Cool. Part 2, as you finish last custom declaration, you notice you misread one word in the instructions. You don't need to identify the questions to which anyone answered yes. You need to identify the questions to which everyone answered yes. So using the same example above, in the first group, everyone, all one person answered yes to 3 questions, which is A, B, and C. Second group, no question, everyone answered yes. Third group. So now we're not looking for unique response count. We're looking for homogeneous response count. I don't know the word for that. The one in which everybody responded to it. And I think that we can reuse part of this. The difference is going to be in our loop logic here. So okay. So what I think we want here is we're going to go through every string, and if the string does not contain it, then we break. And then count plus equals 1. Because basically what this says is for every single string, if the string doesn't contain the character we're looking for, bail out, move on to the next character. I think that's right. I think it's going to be that simple. Oh, I didn't run it. I'm dumb.
Okay, so now let's take this. So now we have groups. We're going to say unique equals groups dot reduce, and then let homogeneous equals groups dot reduce, and the difference is we're asking for the homogeneous response count. And then we're going to print homogeneous. Okay. Or homogeneous. Print unique. That's what's inside that. Okay. So this is already going wrong. X2 always count as 2. So the answer to this one should be 1. Yeah, this isn't right. Did fail equals false, and then did fail equals true, and then if not did fail, then count plus equals 1. Either way, did fail equals false. We reset it, and then let's try again. That was not going to work. I don't know. I can explain at the end here. Because we're getting close to the end. X is 1. Okay, perfect. Nothing in the second one. 7. Okay, let's try this one. 3. VUS, UVS, VUS. Yeah, that looks like it's doing wrong. 3268. Boom. Okay, let's talk about why that wouldn't work really quick. But other than that, I think this is a pretty easy day. Okay, so why this wasn't going to work is, so it was going to, we were doing the count here, and then we didn't have any of this business. So what was going to happen is, if it didn't contain the character cool, it would bail, but the problem is that every time it did contain a character, it was going to get to the count statement. So what we're actually trying to do is we're trying to keep track of it if it ever failed on any of the strings. So that was just like a slight logic error, and this is one of those things that I'm sure most of you have experienced as well, where like if you've been programming long enough, you get to a problem, you make a mistake, and you're like, oh my gosh, I've made that kind of mistake before. And that's one of them where it's like, as soon as I saw what was happening, I was like, yep, I've made this exact kind of mistake before. I know. And so I knew exactly what the issue was. Anyway, so that means that it's pretty straightforward. Pretty straightforward to bail out at the right time. Again, we don't even actually technically need this break here. This just makes the algorithm faster. It just makes it so that we don't have to go through, because at the end, it's going to go through every string, and if any one of them did fail, then it would still catch it. This just makes it so that the first time that we hit a did fail, you can bail out. Again, if somebody knows like a clever trick, like Lance taught me about, I think he called them labeled breaks. Well, let's see if this actually, I don't want this. Yeah, it totally recognizes it and it builds. So this is really cool. So this is a cool trick. I'd definitely be using this at some point, because I know that you have lots of nested loops in admin code. So he taught me that. If there's a cool trick for doing this kind of pattern, because I feel like this is a super common pattern, let me know in the comments. Happy to learn again every single day. All right, well, until next time, thanks for watching, like and subscribe. You know the deal. Tell your friends. Okay, bye.